Hello friends, this is Mani Krishna, and now we are going to see the basic introduction to DSP. So first, before going into the topic, let's see what is a signal. A signal is something which carries valued information, or it is a physical quantity which is varying in accordance with time, space, or many other independent variables. Next, if you consider the analog signal, it is classified into two types: continuous time and discrete in time. So when we give this discrete in time to an analog to digital converter, then we get a digital signal. Next, the basic blocks of a DSP system. What does a DSP system consist of? So first, the analog input signal is given to an A to D converter. The A to D converter internally contains a sample and hold circuit and a quantizer. So when analog input signal is given to a sample and hold circuit, so the analog input signal is sampled based on this sample and hold circuit, and each sample contains a time period of Ts. In the quantizer, the sample and hold circuit output is given to the quantizer. The main role of a quantizer is it will place the amplitudes of different signals in a same amplitude level. Next, the output of the A to D converter is a digital input signal. The digital input signal is given to the digital signal processor. So the main purpose of the digital signal processors we are using here is, it is a special processor which is used only for converting the continuous signals to discrete signals. And the output of a DSP is digital output signal, and it is given a D to A converter, and the output of that will be an analog output signal. Next, advantages. Coming to the advantage of DSP over analog, it is reprogrammable. That is, the program can be modified n number of times and more accuracy. When we compare with these analog signals, the digital signals are more accurate. Easy storage. The storing of these digital programs is very easy, such that this can be stored in magnetic disk storages, etc. Then less sensitive. What is convolution? It is a mathematical way of combining two signals to get a third signal. In this DSP, the most important step is this convolution. So assume for a linear system, we are giving an input and we are getting an output. First, if the input is x of n, then the output will be y of n. Next, if the scaling property is applied, so that is a into x of n is given as input, the output should be a into y of n. Next, if the summing of signals is applied at the input, that is x1 of n plus x2 of n, the output should be y1 of n plus y2 of n. If we combine both these properties, then the input will be a into x1 of n plus a into x2 of n. If that is given to the linear system, and if the output is a into y1 of n and a2 into y2 of n, then it is said to be satisfying the linearity condition. Next, if we give a certain delay in the input, that is x of n minus k is given at the input, then the output should be y into y of n minus k. That is, there should be a significant delay in the output which is given, say, at the input. And if we give the impulse excitation to the linear system which is having a system function as h of n, then the output will be an impulse response. That is, if we convolve any signal with an impulse signal, then the output will be the signal itself. Next, how to do convolution? There are mainly four basic steps to do this convolution. So the first step is folding h of minus k. The second step is giving a delay h of n minus k. Here we assume that this delay is n. Next, the third step is multiplying x of k into h of n minus k. After multiplying, we have to sum the number of samples in the sequence. These are the four steps involved in convolution. So the main formula is y of n equal to sigma k equal to minus infinity to infinity x of k into h of n minus k. If the input sequence x of k contains L1 number of terms and the sequence h of k contains L2 number of terms, then in the output the total number of terms will be L1 plus L2 minus 1.